In this video, I will talk about the relationship between e and log, and how to use this relationship to solve a general exponential problem such as 2 to the power of what gives you 50. A straightforward method is the trial and error method. It's called numerical method because there is no general rule of solving. You just start with a guess. Say we start with a guess of x be 5. Try that out, we get 32. We know it's not the answer, so we keep going by taking small step at a time. We try a power of 5.01. We get slightly greater number. Keep trying till we get 5.64. This time, it gets us close to 50. If you try the next one, it gets a little bit over 50. So we can say that the answer is roughly 5.64. This method should be the last resort if you don't have better options, because it has some issues. First, there is no guarantee you will always find the answer. If you start with the wrong initial guess, then you will be moving further and further away from the truth. Or, even if you start alright, but the step too big, you might also miss the answer. The other problem is it's time consuming, and you have no control over that, because it will only stop till you get an answer, but you have no idea when that will be. Actually, even evaluating this exponential term could be complex. You can break it down into an integer power term and a real power term. The integer one is easy to do, you just multiply 2 5 times. But what is this 2 to the power of 0.01? We end up with another puzzle, asking us what number y is when multiplied by itself 100 times will give you 2. Again, there is no general rule in solving this, so we start with a guess and see how that goes. If it's not good, then we move on to the next guess and the next, till we get an answer close to 2. Here we might stop and claim that it's roughly 1.006956. Then we use it to evaluate this exponential term to get 32.22258. And that's just one evaluation. Of course, there are other trial and error methods that are better than the one here. But we have a better way by using the relationship between e and log. Let's see how to do that. If we change the base here from 2 to e, then what is x? We know that one unit growing continuously at a rate of r will become e to the power of r. We also know that log is the operation that will give us back the growth rate. So if we do log operation on the final result, we should get the rate r. So that means what's on top of e can be extracted by doing log operation on the final result. Hence log 50, and we know how to compute log. But unfortunately, we have 2 here instead of e. So can we convert it to a base of e? We know that one unit growing continuously will become 2 units. So log 2 is the growth rate. We know that the growth rate can be put on top of e to express the final outcome. So 2 can be written as e to the power of log 2. Hence, we can rewrite a base 2 problem in terms of base e as e to the power of log 2, then raised to the power of x. These two powers can be combined as a product. So the power term becomes log 2 times x. Use that on top of e gives us 50. To see why the power terms can be multiplied, we use a simple example. 5 squared, then raised to the power of 3, equals to 5 to the power of 6. Okay? Then we take log on both sides. The log operation on the left side is only symbolic, because we know whatever on top of e falls off. So we know it should be log 2 times x, equals to log 50. This way, we get x as a ratio of the 2 logs. Remember, we have a method to compute any log, so we use this formula to compute log 50 and log 2 to get a final answer. In reality, we could have any base for an exponential relationship. So for the more general case, we call that x as the logarithm of y with base b. When the base is e, people gives it a special name, ln, and the base can be omitted. This is the natural log. Natural log deserves special attention because any base b will be converted to e to the power of log b. So the original base b problem becomes a base e problem. This way, any log can be calculated as the ratio of the two natural logs. The natural log can be computed directly. Remember in school we were taught to use the calculator. It has natural log function. This way, calculator only needs to be wired to do the natural log operation. You can combine them to calculate log for any basis. In our next video, I want to talk about why do we even care about solving this problem in the first place.